welcome everybody to the Western Bird Banding Association webinar series. I'm Danielle Kashubi with the Institute for Bird Populations and the president of the Western Bird Banding Association. I'm glad to see so many faces here. I'm going to hand it on over to Colin. So Colin, it's all yours.
All right, sounds good. My name is Colin Woolley, and I am a board member of the Western Bird Banding Association, and I work with Bird Conservancy of the Rockies out here in Colorado. I'm happy to introduce my colleague at Bird Conservancy, Rob Sparks. Rob's a senior spatial ecologist, but in truth, he wears many hats here at Bird Conservancy. He has worked with a wide variety of spatial data sets from migratory birds, including geolocator data on Swainson's thrushes, western tanagers, and chestnut-collared longspurs. Rob also coordinates a community science program monitoring eastern screech owls in the Fort Collins, Colorado area. But the hat he's wearing tonight is that of our Black Swift project manager, project I've been lucky enough to join along with in the field a number of times. And Rob will be taking us through some recent research on this elusive, enigmatic species from some long-term study sites in Colorado. And with that, I will turn it over to Rob.
Great. Thanks, Colin. I'm going to share my screen here. Okay, does it look good?
It looks good. Looks good.
Okay. All right. Well, thanks for inviting me to present tonight. I'm going to be focusing on the Black Swift movement ecology component of our Black Swift research. And I first want to acknowledge our research team here. Colin just spoke, and he's here on the bottom left of this picture. We're at Fulton Resurgence Cave, one of our banding sites. And then Greg Lewandowski, he's an independent researcher that also helps on the project. So they provide a lot of expertise. You could see myself extracting a swift here on the bottom right picture. But so tonight, the outline for tonight is that I'll just kind of focus on the non-breeding data set that we recovered and discovered a novel bird behavior. It's quite amazing behavior that this species does during the non-breeding season. And if I have time, I'll touch on the breeding GPS data set that we also recovered. And with that, I'll just start. Thank you. Yeah, so a little bit about the natural history of this species. It breeds near waterfalls, canyons, and caves. You could see the breeding distribution for the Black Swift on the map here. The orange represents breeding, blue is wintering, yellow is the migratory path. So it has a broad, so there's three subspecies. So the three subspecies has a broad range. Hopefully you could see my pointer. So there's a Caribbean population and the Caribbean Central American population, and then there's North American population. So we're going to be focusing on the North American population here. And so this species has some specific nesting requirements. It needs flowing water or some type of moisture in the vicinity of the nest. It needs some vertical relief, so as well as aerial access. It doesn't like flying through lots of canopy cover, so it needs some relief. It has long wings. It's an aerial insectivore, so it has short legs as well, so it needs a little bit of relief to take flight from its nest site. The nest also, there needs to be some type of ledge or crack it could position its nest in, as well as some shade. And usually there's moss in the vicinity of the nest for nest building. This species migrates to the Amazon in Brazil, and that was discovered in 2012 where we attached some geolocators to some birds in Colorado. So it's somewhat of a recent discovery. And then this project is building upon what we've learned with the geolocators. It has one egg, so it has low fecundity. So that kind of implies that conserving their nests will have a big impact on population growth. And then you could see a swift on the nest here, a mossy nest. I believe this nest is from the Caribbean population. Here, its breeding phenology is from June to August. And this graph is showing that timeline for each from breeding to migration to non-breeding. So migration in the fall starts in September, going into October, and then spring migration is from May to June, and then the non-breeding seasons from October to May. So what's the current status of this species? There's been documented declines, about 94% of its population, but there's a lot of uncertainty around those estimates. They're based off of breeding bird survey data, and there haven't been any abundance estimates that account for detection probability. So there's still a lot to learn about the status of the species, but we know that it's declining, and unfortunately, the aerial insectivores as a guild are declining, and it's listed on a lot of state species of greatest conservation need lists. It's a species of special concern, and the Partners in Flight listed as a species of continental concern. And the Road to Recovery effort, it's an effort that came out of the 3 billion birds lost paper, lists it as a tipping point species, a tier 2 species. So ultimately, our goal is to develop some effective conservation plans and recommendations. In Canada, it was listed as endangered in 2019. That's where the majority of the population of the North American black swift population occurs. But we don't really know. They're still learning where the nests are in Canada. And then in Mexico, Central America, and the Caribbean, we don't really know the status. So I invite, other members or collaborators that live in these countries to try to learn what's the status and what are those species doing. Do they stay on their breeding grounds year round, or do they go to the Amazon as well? So this map here is just showing the potential distribution of swifts in Colorado. You could identified by the gray dots there. And I do, just as an aside, I do want to mention that we're working with Colorado Parks and Wildlife. We started a statewide monitoring program across the state to estimate abundance and detection probability. And we also, the Black Swift Working Group developed a standardized monitoring protocol. So we were able to assess that protocol, and we're hoping to get some trend estimates and estimate abundance. So that's a different presentation, but I did want to mention that. So on the bottom part, you can see the picture is showing a waterfall, and there's a black swift nest on the middle right of this waterfall. And black swifts can nest, there could be single nests, there could be it's common to have one nest to two nests, and then there's larger colonies as well with 20 nests, 15 nests. So there's a lot of variation there. So if you could see my cursor, our study sites are in Sangre de Cristo Mountains and Zapata Falls, and that's right next to the Great Sand Dunes National Park in the San Luis Valley. It's a beautiful place. And then we also have a site where we do use handheld nets in Box Canyon State Park in Ouray. And then there's a site up in White River National Forest. That's a cave where we also band. And that's just north of Rifle. So here's the Zapata Falls site. Most of the wing activity device data is coming from the Zapata Falls site, where this site's at 9,000 feet, and it's a spectacular site. It's surrounded by pinyon juniper habitat, and then just above the waterfall here is we get into mixed conifer, and you could see. I think is that Colin or Greg? We're kind of trying to look above the waterfall. So above the waterfall, as it weaves through the canyon, there's a large colony that's nesting on the side of the canyon wall here. Here in this video, pay attention to the upper right part. You can see some birds flying in. So this is at Zapata Falls. And so there's 2 birds in the net right now. And we use a double stacked mist net for this site. So we're stacking 2 8-foot conduit poles. And then we have 2 mist nets stacked on top of each other. Colin's extracting a swift here. And sometimes it's hard to see what side of the net they fly in, but I'm on the bottom left. We just captured another bird. But that's our setup for Zapata Falls. And we try to be as effective as possible as they come in and out in groups. So after we capture them at Zapata Falls, this is a video showing me attaching a GPS tag on a swift. We use the backpack harness method. In this diagram on the left, you could see the loops. So we have a head loop, and then the loops around the wing, and then we attach it to the back of the device. We could do it pretty quickly. And then we also attached accelerometers, so wing activity devices as well. So as I mentioned, I'm going to focus on what we've learned during the non-breeding season. So this is using the wing activity devices. And you could see one on the back of the Swift here. That's what they look like. They also have geolocator, the ability to capture the spatial location through geolocation. And so what we were interested in is, are they aerial roosting like their European counterparts, the common swift? And we thought that they probably do, but it was unknown. And then we are also wanting to confirm the wintering area from the 2012 paper. And then, so in looking at the data, there were some unexpected nocturnal ascents, and they were, so flight activity and flight altitude seemed to be driven by moonlit nights. And so we published a paper with our collaborators out of Lund University at the MoveCan lab, and it came out in 2022. And it's open access, so anyone could read it. So the first, so we were able to confirm their wintering area. The map on the left is showing our 2012 paper, so you could see that we have a overwintering area here in Brazil, in the Amazon, and then the map on the right showing the geolocators, wing activity devices, accelerometers, and they are, they coincide with the 2012 paper, so that's good. And we're also interested in learning about the migratory connectivity of other populations. So not just black swifts in Colorado, but what are the California populations going, and where are the Canadian populations going? So we're still wanting to figure that piece of the puzzle out, because it'll have strong conservation implications. And during this paper, there was a bird that carried a wing activity device for 2 seasons, and it broke the longevity record, 17 years. And then the next year we recaptured another bird that broke the record, and then this year we recaptured a bird that broke the record again. So now they're at the longevity record is at 19 years. So it's an amazing how long these birds can live. Here I did want to just show an animation of 4 GPS tags that we recovered from Zapata Falls. So here you could see the date is in the upper top part of the animation, and you could see some movement. So each dot represents a GPS tag, and they're color coded, but you can't really see the altitude. That supposedly the colors also represent the flight altitude. You can see one coming down west of the Sierra Madres, and then 2 more are following the leader here, and they're going on the east side of the Sierra Madres, and then this one's jumping the Gulf. And they all kind of come together in Central America and the isthmus there, and some jump over straight to their non-breeding area, and then one kind of follows the isthmus into Colombia. And then there's the third one that also went to the west side of the Sierra Madres, hugging the coast there. So with the GPS tags, we're able to get really precise locations. So now we're talking about, having a location with a precision of up to, 1 meter, 3 meters. So they all come down to the Amazon, and they seem to be kind of really coalescing and in close proximity. So now just switching back to the accelerometer data set to look at, we looked at their wing activity, so flight activity and flight altitude in response to day phases and moon phases. So we're defining those phases by looking at the elevation of the sun or the moon above the horizon. And I'm not going to get into the details, but that's kind of what we're looking at. Here's the results for the wing activity data set. We could see in the top panel A, if let's just focus on that panel, we could see, so the white in this box represents maximum wing activity, and the dark represents minimum wing activity. And on the x-axis, we have months of the year, and then on the y-axis, we have time of day. And there's two days on this graph. But you could see that during the months of September through May, they were 99.6% of the time they were airborne. So that confirms that they are aerial roosting. And then you could see in June the minimum, so they're roosting at their nest site. And then you could see if you focus on panel C here, we're also able to derive altitude. The accelerometer has a pressure sensor, and you can notice these diagonal bands, and these, cyclical patterns are representing, they're increasing in altitude during full moon periods. And then you could also see the bottom panel D temperature is decreasing as they increase in altitude. So it's quite an amazing behavior that they're doing. And to focus a little bit on the effects of the lunar cycle. So again, if we focus on the top graph here, we could see the months on the x-axis, and then we'll time of day on the y, and then lunar phase on the bottom part of the graph. And so the yellow colors indicate higher altitude. So, and these top circles here represent the lunar phase. So full moon, first quarter, new moon, third quarter. And during the full moon here, the yellow line corresponds with full moon. You can see that they're increasing in altitude. So during full moons, they're up about 6,500 feet. And then during the new moon, they're at 2,300 feet. And then during the daytime, about 1,600 feet. And then the bottom graph is just showing the similar response using lunar illumination on the x-axis, flight altitude on the y, as well as lunar altitude. So they certainly are changing their flight behavior in response to periods around the full moon. And it's so amazing. There was a lunar eclipse in January 20th. So this allowed us to see the direct effect of moonlight on flight altitude. So the top panels showing, the lunar altitude, and basically, the full moon corresponds with the top of this peak here. And then let's focus on panel B. You could see its flight altitude during the January 21st. The yellow dashed vertical line is the start of the lunar eclipse. The shaded areas here are just corresponding with day and the nighttime periods. So we could see a sharp drop in altitude during the lunar eclipse. And then if we focus on the right panel D here, that's just the zoom in of the lunar eclipse. They drastically drop in flight altitude, and then after a few hours they regain altitude. So that's it was quite amazing to see that. And we think they're foraging during the moonlight. I mean, that's still what we think is happening. We weren't able to say with certainty, or they could also be avoiding predators. We don't think that that's necessarily the case, just by the the cyclical pattern we're seeing during moonlit events. But that's what we're thinking. And there was a paper just published recently that looked at the common swift, alpine swift, and the pallid swift, and they were seeing similar behaviors with moonlight for the common and the pallid, but not the alpine swift in Europe anyways. So I think I'm running out of time here. Colin, how much more time do I have?
What do we think, Danny? Probably another couple minutes.
Yeah, just
Okay.
a couple more, and then we'll open it to questions.
Okay, sweet. I'm gonna skip through the breeding period GPS tag. So that conclude what we learned during the non-breeding season. So here I just want to show quickly so we're developing some home range distributions, utilization distributions. This is the bird box canyon, and we could try to figure out what they're doing during the breeding season, which is currently unknown. But yeah, so I just want to acknowledge our funders and partners, and happy if we have time for any questions.
Let's do a couple questions. So I think there was a couple in the chat. Give me a second here. Sorry, I should have been better organized here. So I think Carl said, as aerial insectivores, do we have any ideas as to which insect taxa represent predominant food sources for black swifts, I wonder? And he says, I'm intrigued by nocturnal flights on moonlit nights, and it might these be foraging flights, I wonder. And someone did provide a paper, but maybe people would just like to hear what you think, Rob.
Yeah, so I did mention that we do think they're foraging. So that's something we think they're doing, but we weren't able to be certain with the data. We're hoping to look at some there's some modeling you could use to look at different behavioral states, and we were hoping to try to tease that out in a follow-up paper. Good question. In terms of what taxa of insects they're eating, they have been seen. Kim Potter published a paper on the black swift diet for the birds in Colorado, and they're seeing it's a variety of ants. There's lots of mayflies. What we've seen personally, we've seen some moths as well, in the bolus if we're capturing swifts in the evening. So they'll eat any insect that's up there in the air. So there's a wide variety. Historically, it's been reported that they eat ants, flying ants, when there's blooms and ants.
Awesome. Okay, we have another question. Have you been able to work with the California population?
No, so we're in the process of hoping to be able to work with populations in California. I think unfortunately there's been some documented declines along the coast there. And yeah, no, we'd love to, and we're working on that.
And similarly, a question, is any similar work being done in Canada?
Yeah, so in Canada, they're still trying to figure out where the nests are. At known nest sites, they do, like at Banff National Park. There's some monitoring going on there. No tagging. I'm in contact with Environment and Climate Change Canada, and they're wanting to tag. So they have found some new sites. So they're wanting to tag in the near future.
Okay, we'll have a couple more questions here. What's the main reason they might fly higher during the full moon?
Yeah, so I think it's related to there's so insects. So there have been some papers that document the height of the insects. So the insects are flying during moonlit nights as well. So that correlation, there's a correlation. Now, in terms of specific heights, like I think from reading the most recent paper, the depending on the insect, there are some that have distributions that they fly at during at certain elevations. So there are some distributions specific to insects. Now, I think there's still a lot to learn about what's going on in the Amazon, especially in terms of insects. We weren't able to find any papers on that actually, and for the Amazon itself. So that's a good question.
Just riffing off of the Amazon question, they're not landing during the wintering season when they're in the Amazon. Is that correct? And so if that's the case, what's taking them to that particular section? Or am I wrong on that, not landing?
No, you're right. I mean, that's the aerial roosting. That's amazing that they don't land. I mean, There was maybe one instance of an individual landing, but 99.6 of the time they were in the air. And so the Amazon is really high in insect diversity. So that's probably one reason. So there's available food resources. Well, we hope it stays that way. There's Amazon's under a lot of threats, deforestation, the mining, there's light pollution. So, but I think they're drawn there because of the high insect diversity and abundance.
Awesome. Okay, one last question, and then I'm gonna refer you to the chat because there are a few more questions, and I don't know if you can answer them in the chat, but we'll go from there. Actually, two questions. Did you experiment tags damaged by roosting in the nest behavior? I guess the question is were the tags damaged by roosting or nesting?
So we didn't see any direct evidence of the tags we recovered from nesting. They use their small legs. They perch on the rock walls or near the ledge, so the back's not in contact with the nesting, the wall, the rock face. So, but there was a lot of wear due to weather on the tags. So luckily, we also inspect around the wing and their sternum, and they looked like there was hardly any abrasion, so that was good to see.
Good. Okay, and then the last question is you didn't get to finish this slide presentation. Do you have a copy of this that we could put on the Western Bird Banding Association's site? I'll put this video on, but are these slides available or are not available?
I could put some of them on there. There's a few slides that we still haven't published the breeding data sets. It's preliminary, but yeah, I could probably share most of them. Yeah.
Okay, if you send them to me, I'll post them when I post the video.
Okay.